The architectural feats of ancient civilizations stand as enduring testaments to human ingenuity, reflecting the cultural, religious, and social dynamics of their eras. Among these, the Egyptian pyramids, Greek temples, and Roman amphitheaters are particularly notable. The Egyptian pyramids, such as the Great Pyramid of Giza, constructed around 2589 to 2566 BC, exemplify the Egyptians' mastery in engineering and their profound religious beliefs. These monumental structures, primarily serving as tombs for pharaohs, were built using locally available materials like limestone and mud brick. The construction techniques, including the post and lintel method, allowed for the creation of massive edifices aligned with astronomical events, underscoring the Egyptians' advanced understanding of both architecture and astronomy. In contrast, ancient Greek architecture, flourishing between 900 BC and the 1st century AD, is renowned for its temples, such as the Parthenon in Athens. These structures were characterized by formalized elements, including the Doric, Ionic, and Corinthian orders, which emphasized balance and proportion. The Greeks' focus on aesthetics and harmony influenced not only their own structures but also left a lasting legacy on Western architecture. The Romans, drawing inspiration from the Greeks and Etruscans, developed their unique architectural style, evident in structures like the Colosseum. Roman architecture showcased innovations such as the use of arches, vaults, and concrete, enabling the construction of vast public spaces and infrastructure, including roads and aqueducts. These developments facilitated urbanization and the spread of Roman culture across their empire. Additionally, recent archaeological discoveries continue to shed light on ancient architectural practices. For instance, excavations in Pompeii have unveiled a lavish private bath complex, highlighting the sophistication of Roman domestic architecture and their emphasis on social and public life. Reuters. Similarly, studies suggest that hydraulic systems may have played a role in constructing Egyptian pyramids, indicating a more advanced technological prowess than previously understood. The Times. These findings not only deepen our appreciation of ancient architectural achievements but also underscore the continuous human quest for innovation and expression through building. The architectural achievements of ancient empires such as Egypt, Greece, Rome, Babylon, and Persia not only reflect their cultural and religious values but also showcase their advanced engineering and artistic skills. In Egypt, monumental structures like the Pyramids of Giza, constructed around 2589 to 2566 BC, exemplify the Egyptians' mastery in engineering and their profound religious beliefs. These monumental structures, primarily serving as tombs for pharaohs, were built using locally available materials like limestone and mud brick. The construction techniques, including the post and lintel method, allowed for the creation of massive edifices aligned with astronomical events, underscoring the Egyptians' advanced understanding of both architecture and astronomy. In contrast, ancient Greek architecture, flourishing between 900 BC and the 1st century AD, is renowned for its temples, such as the Parthenon in Athens. These structures were characterized by formalized elements, including the Doric, Ionic, and Corinthian orders, which emphasized balance and proportion. The Greeks' focus on aesthetics and harmony influenced not only their own structures but also left a lasting legacy on Western architecture. The Romans, drawing inspiration from the Greeks and Etruscans, developed their unique architectural style, evident in structures like the Colosseum. Roman architecture showcased innovations such as the use of arches, vaults, and concrete, enabling the construction of vast public spaces and infrastructure, including roads and aqueducts. These developments facilitated urbanization and the spread of Roman culture across their empire. Additionally, recent archaeological discoveries continue to shed light on ancient architectural practices. For instance, excavations in Pompeii have unveiled a lavish private bath complex, highlighting the sophistication of Roman domestic architecture and their emphasis on social and public life. AP News. Similarly, studies suggest that hydraulic systems may have played a role in constructing Egyptian pyramids, indicating a more advanced technological prowess than previously understood. The Scottish Sun. These findings not only deepen our appreciation of ancient architectural achievements but also underscore the continuous human quest for innovation and expression through building. The ancient architectural marvels of Angkor Wat, Machu Picchu, and Petra stand as enduring testaments to the ingenuity and cultural richness of their respective civilizations. Each site offers a unique glimpse into the architectural prowess and societal structures of the ancient world. Angkor Wat, Cambodia. Angkor Wat, located in present-day Cambodia, is the largest Hindu temple complex globally and a masterpiece of Khmer architecture. Constructed in the early 12th century by King Suryavarman II, it was initially dedicated to the Hindu god Vishnu. Over time, it gradually transformed into a Buddhist temple, reflecting the region's religious evolution. The temple complex is meticulously designed to represent Mount Meru, the center of the universe in Hindu and Buddhist cosmology. It features a series of concentric galleries, each elevated above the last, culminating in a central tower that rises 65 meters above the ground. The outer walls are adorned with extensive bas-reliefs depicting scenes from Hindu epics like the Ramayana and Mahabharata, as well as historical events and celestial beings. The intricate carvings and architectural harmony of Angkor Wat exemplify the advanced engineering skills and artistic achievements of the Khmer Empire. Designated a UNESCO World Heritage Site in 1992, Angkor Wat continues to be a symbol of Cambodia's cultural heritage and attracts millions of visitors annually. Wikipedia. Machu Picchu, Peru. Machu Picchu, often referred to as the Lost City of the Incas, is an Incan citadel set high in the Andes Mountains of Peru. Believed to have been constructed in the 15th century during the reign of Inca Emperor Pachacuti, Machu Picchu remained hidden from the Spanish conquistadors and was rediscovered by American historian Hiram Bingham in 1911. The site comprises approximately 200 buildings, including temples, residences, and terraces, all constructed with precisely cut granite stones that fit together without mortar, a technique known as ashlar masonry. The city's layout is divided into two main areas: the agricultural sector, with its extensive terraces, and the urban sector, featuring plazas, residences, and religious structures. Notable structures include the Temple of the Sun, the Intihuatana stone, a ritual stone associated with astronomy, and the Room of the Three Windows. Machu Picchu's strategic location and sophisticated construction techniques reflect the Incas' advanced understanding of engineering and their deep connection to the natural landscape. Designated a UNESCO World Heritage Site in 1983, it remains one of the most visited tourist destinations globally. Johnny, Africa. Petra, Jordan. Petra, located in present-day Jordan, was the capital of the Nabatean kingdom in the 4th century BC and later became a major trading hub under Roman rule. The city is renowned for its rock-cut architecture and sophisticated water management systems. The most iconic structure is Al-Hazna, or the Treasury, a monumental facade carved directly into the sandstone cliff face, showcasing a blend of Nabatean and Hellenistic architectural styles. Other significant structures include the monastery, Ad-Dair, the Great Temple, and the royal tombs, all demonstrating the Nabateans' advanced engineering skills and artistic expression. Petra's strategic location along ancient trade routes facilitated the exchange of goods and cultures, contributing to its prosperity. Designated a UNESCO World Heritage Site in 1985, Petra continues to captivate visitors with its historical significance and architectural grandeur. ThoughtCo. These ancient sites not only exemplify the architectural achievements of their civilizations but also offer profound insights into the cultural and historical contexts in which they were developed. Their enduring legacies continue to inspire awe and scholarly interest, underscoring the universal human endeavor to create structures that transcend time and embody the spirit of their creators. The Renaissance, spanning the 14th to the 17th centuries, marked a profound transformation in European architecture, characterized by a revival of classical Roman and Greek principles, a focus on symmetry and proportion, and the integration of art and science. This period witnessed a deliberate departure from the Gothic style, embracing a more harmonious and rational approach to design. Origins and influences. The Renaissance originated in Italy, particularly in Florence, during the early 15th century. Architects and scholars, inspired by the ruins of ancient Rome and the writings of Vitruvius, sought to rediscover and emulate classical architectural forms. This movement was not merely a revival but an evolution, blending ancient principles with contemporary needs and aesthetics. Encyclopaedia Britannica. Key characteristics. Renaissance architecture is distinguished by several key features. Symmetry and proportion. Buildings were designed with a focus on balanced proportions, reflecting the mathematical precision found in classical architecture. Use of classical orders, the incorporation of columns, pilasters, pediments, and arches, adhering to the classical orders Doric, Ionic, and Corinthian became standard. The Metropolitan Museum of Art. Domes and arches. The revival of the dome, exemplified by Filippo Brunelleschi's design of the Florence Cathedral's dome, and the widespread use of arches, were significant innovations. Emphasis on geometry. Architects employed geometric principles to achieve harmony and order in their designs, reflecting a deep engagement with mathematics and science. Notable architects and structures. Several architects were instrumental in shaping Renaissance architecture. Filippo Brunelleschi, renowned for engineering the dome of the Florence Cathedral, a feat that combined engineering prowess with aesthetic elegance. Leon Battista Alberti, a polymath who authored influential treatises on architecture, promoting the application of classical principles in contemporary design. Donato Bramante, his design for St. Peter's Basilica in Rome initiated a project that would evolve over centuries, influencing the course of Western architecture. Michelangelo Buonarroti. Beyond his sculptural masterpieces, Michelangelo contributed to architecture, notably in the design of the Laurentian Library in Florence. Iconic structures from this era include Florence Cathedral, Duomo di Santa Maria del Fiore. The cathedral's dome, engineered by Brunelleschi, remains a marvel of Renaissance engineering. St. Peter's Basilica, a monumental church in Vatican City, its construction spanned the Renaissance and Baroque periods, epitomizing the grandeur of Renaissance architecture. Palazzo Medici Riccardi, an example of Renaissance palatial architecture, showcasing the use of rusticated stonework and harmonious proportions. Impact and legacy. The Renaissance's architectural innovations laid the foundation for subsequent architectural developments, influencing Baroque, neoclassical, and even modern architectural styles. The period's emphasis on humanism and the integration of art and science continue to inspire contemporary architecture. The study of Renaissance architecture offers valuable insights into the cultural and intellectual currents of the time, reflecting a society's values and aspirations. In summary, Renaissance architecture represents a pivotal era where the rediscovery of classical knowledge, combined with innovative design and engineering, led to the creation of structures that have endured for centuries, continuing to inspire awe and admiration. The Industrial Revolution, commencing in the late 18th century, profoundly transformed architecture by introducing new materials, construction techniques, and building types that reflected the era's technological advancements and societal shifts. This period marked a departure from traditional building methods, embracing industrial materials such as cast iron, steel, and glass, which enabled the creation of structures with unprecedented scale and functionality. Introduction of industrial materials. The mass production of iron and later steel during the Industrial Revolution revolutionized architectural design. These materials allowed for the construction of larger, more durable structures with greater spans and heights than previously possible. The use of iron beams and steel frames became standard, facilitating the development of expansive factory buildings, warehouses, and bridges. The incorporation of glass, particularly in the form of large windows and skylights, not only enhanced the aesthetic appeal of buildings but also improved interior lighting and ventilation. John Gaber's blog. Emergence of Industrial Architecture. Industrial architecture emerged as a distinct style during this period, characterized by functional design and the use of industrial materials. Buildings were designed to accommodate the processing, manufacturing, distribution, and storage of goods and resources. This approach led to the creation of utilitarian structures that prioritized efficiency and functionality over ornate decoration. The architectural designs considered the safe flow, distribution, and production of goods and labor, reflecting the era's emphasis on industrial efficiency. Wikipedia. Notable examples of industrial architecture. Several iconic structures exemplify the impact of the Industrial Revolution on architecture. The Iron Bridge, Colebrookdale, England, 1775 to 1779. This was the first industrial structure made entirely of cast iron, marking a significant advancement in engineering and architectural design. Its aesthetics were far from the ornate styles of the past, reflecting the utilitarian ethos of the Industrial Revolution. Citalia Restero. Crystal Palace, London, England, 1851. Designed by Joseph Paxton for the Great Exhibition, the Crystal Palace was a pioneering structure made of cast iron and glass. It showcased the potential of industrial materials and techniques, featuring a vast glass and iron framework that allowed for expansive interior spaces. Wikipedia. The Gas Holders of London, England, 19th century. These structures were essential for gas storage during the Industrial Revolution. Although now obsolete, many gas holders have been preserved and repurposed for modern use, highlighting the enduring legacy of industrial architecture. The Times. Impact on urban development. The Industrial Revolution spurred rapid urbanization, leading to the development of new building types and infrastructure. Railways, factories, and warehouses became prominent features of the urban landscape, reshaping cities and influencing architectural styles. The need for efficient transportation and storage solutions led to the construction of large-scale industrial buildings, often characterized by their functional design and use of industrial materials. Rethinking the future. Legacy and preservation. The architectural innovations of the Industrial Revolution have left a lasting legacy, influencing modern architecture and urban planning. Many industrial structures have been preserved and repurposed, serving as reminders of the era's technological advancements and cultural shifts. For instance, the conversion of gas holders into luxury housing developments in London reflects a broader trend of integrating industrial heritage into contemporary urban life. The Times. In summary, the Industrial Revolution was a pivotal period that transformed architecture by introducing new materials and construction techniques, leading to the creation of structures that were both functional and emblematic of the era's technological progress. The legacy of this period continues to influence architectural design and urban development today. The future of architecture is poised to be shaped by a confluence of technological advancements, environmental imperatives, and evolving societal needs. As we look ahead, several key trends are emerging that promise to redefine the built environment. Sustainable and regenerative design. A paramount focus in future architecture is sustainability, with an emphasis on regenerative design principles. This approach goes beyond minimizing environmental impact to actively restoring and enhancing ecosystems. Architects are increasingly integrating renewable energy sources, utilizing sustainable materials, and implementing green building practices to create structures that harmonize with their surroundings. The adoption of passive design strategies, such as optimizing natural light and ventilation, is also gaining traction, contributing to energy efficiency and occupant well-being. New York Post. Technological integration. Advancements in technology are revolutionizing architectural design and construction. The integration of artificial intelligence, AI, and machine learning is enabling architects to generate complex, innovative designs with greater efficiency. For instance, firms like Zaha Hadid Architects are leveraging AI tools to expedite the design process, allowing for rapid prototyping and enhanced creativity. The Times. Additionally, the use of parametric and computational design techniques is facilitating the creation of adaptive, context-responsive structures that push the boundaries of traditional architectural forms. Novature. Smart and adaptive buildings. The future of architecture is increasingly characterized by smart buildings equipped with advanced technologies that enhance functionality and user experience. These structures incorporate sensors, automation systems, and data analytics to optimize energy consumption, improve security, and provide personalized environments for occupants. The integration of Internet of Things, IoT, devices allows for real-time monitoring and adjustment of building systems, leading to more efficient and responsive spaces. Actitime. Modular and prefabricated construction. To address the demand for faster and more cost-effective construction, modular and prefabricated building methods are gaining prominence. These approaches involve assembling components off-site in controlled environments, which are then transported and assembled on-site. This method reduces construction time, minimizes waste, and allows for greater precision in building quality. The flexibility of modular design also facilitates the creation of adaptable spaces that can be easily reconfigured to meet changing needs. Architizer. Biophilic design. There is a growing emphasis on biophilic design, which seeks to connect occupants with nature through the incorporation of natural elements into the built environment. This includes the use of natural materials, the integration of indoor plants, and the maximization of natural light. Biophilic design has been shown to enhance well-being, reduce stress, and improve productivity, making it a central consideration in future architectural projects. www.liveahome3d.com. Vertical and adaptive reuse architecture. As urban populations continue to grow, there is a shift towards vertical construction to maximize space efficiency. High-rise buildings are being designed not only for residential and commercial use but also to incorporate green spaces, communal areas, and mixed-use functionalities. Additionally, adaptive reuse of existing structures is becoming a sustainable practice, breathing new life into old buildings and preserving cultural heritage while meeting modern needs. Novature. Climate-responsive design. Architects are increasingly adopting climate-responsive design strategies to address the challenges posed by climate change. This includes designing buildings that are resilient to extreme weather events, utilizing materials and construction methods suited to local climates, and implementing water and energy conservation measures. The concept of sponge cities, which involves creating urban areas that can absorb and reuse rainwater to mitigate flooding, is an example of such innovative approaches. Financial Times. Cultural sensitivity and community-centered design. Future architectural practices are placing greater emphasis on cultural sensitivity and community engagement. Designs are being tailored to reflect the cultural, historical, and social contexts of their locations, fostering a sense of identity and belonging among residents. Community-centered design involves stakeholders in the planning and development process, ensuring that buildings and spaces meet the specific needs and aspirations of the people who use them. Brewer Smith Brewer Group. In summary, the future of architecture is characterized by a harmonious integration of technological innovation, environmental stewardship, and a deep understanding of human needs and cultural contexts. Architects are embracing new materials, construction methods, and design philosophies to create spaces that are not only functional and aesthetically pleasing but also sustainable, resilient, and responsive to the evolving challenges of the 21st century.